Hello there, and welcome to the ninth episode of Dev Conversations, where we host developers that contribute to the Swift tooling ecosystem. Today we have someone that's been around for a long time in the iOS community, and is the author of an extremely popular tool, SwiftFormat. Hey Nick.
Hey.
How's it going?
It's good, thanks.
Yeah, so last year it was quite a surprise for me when I was joining Swift Heroes, the conference, and I looked 3 rows behind me and I saw you. So that's where we met first time.
Yeah, I was there anonymously.
Yeah, and I've been wanting to chat about these topics that we have for today for a while, and I've been trying for a while to reach you, and I'm happy we found the time. Before we jump into SwiftFormat, can you tell me a little bit about your early days as a programmer?
I mean, I've been interested in programming since I was a kid, really. I didn't do a computer science degree. I didn't do a traditional computer science degree. I actually did electronic engineering at university, and then kind of realized I'd made a huge mistake and did a year of sort of computer science catch-up stuff, and then got a job working as a front-end web developer, which wasn't really software engineering in any meaningful sense at the time. It was kind of just HTML and CSS, but it was the first job I could get that was kind of vaguely adjacent to my interests. And so for the first few years, I was mostly just tinkering and doing my own programming stuff, not really in my career. My big break, if you like, came in 2009 when I was working still as a front-end web developer, and I'd been doing a lot more JavaScript by that point. That was kind of like the heyday of like jQuery and all of that kind of stuff. So like, front-end web development was becoming more of a software engineering discipline at that point, and we were writing a lot more code. Our client at the time asked if anybody knew anything about iPhone apps and whether we could build an iPhone app. And of course, our salespeople were like, "Oh yeah, sure, we know all about that." And then internally, it was like, "Okay, does anybody actually know about this?" And then I'd got a book on development. I didn't even have an iPhone at that point in time, but I was, it looked like it was something that would be interesting to get into. So I stuck my hand up and said, "Yeah, I know how to do that." And that was kind of where it went from that point on.
So that's how you started on iPhone OS.
Yeah.
Still, yeah. So I assume you had a Mac.
Yeah. I mean, I'd been an Apple fan for many years. I think I didn't get the first generation iPhone, but I got the second, like the iPhone 3G, pretty much as soon as it came out in the UK.
And then a few years later, you wrote the CoreAnimation book. How did you jump from a regular developer who just started developing on iOS to an author of a book on CoreAnimation?
It's a great question. So, I mean, when I first started doing iPhone development, there wasn't really a big open source community at all around iPhone and Objective-C. So almost everything you wanted to do, if it wasn't something that was built in, you kind of had to do it yourself. And I noticed, like in my work, I was working at an agency, so we did a lot of kind of fairly short projects for different clients. And a lot of patterns kept repeating, things we needed over and over again. And often clients wanted, or the designers working on the client accounts wanted to use what they assumed were sort of out of the box things that you'd see in all of Apple's apps. And one of the obvious ones at the time was CoverFlow. Like Apple used CoverFlow everywhere, but Apple didn't give you CoverFlow as a component. And there was a couple of libraries out there that tried to replicate CoverFlow, but this was I'd been doing iOS for over a year at this point, so I had a reasonable idea what was going on. And I'd sort of figured out this kind of layering of, underneath UIKit, you had CoreAnimation that was actually doing the heavy lifting. And I'd learned that CoreAnimation actually had some 3D capabilities. But the only libraries I could find that did anything like CoverFlow were all using OpenGL. They were basically doing everything from sort of first principles, which wasn't really like very easy to integrate into a user interface. If you wanted to have buttons and interactive controls inside your carousel views, then there was no way to do that really. They were just rendering images. So I thought, well, I mean, CoreAnimation can rotate things in 3D. Why don't I just do it that way? And then, as I said, like a lot of the time, these patterns kept repeating. And, we needed the same thing over and over again. But because we were doing work for clients, if we wrote some code for one client, we couldn't just use it for another client because they'd paid for us to write the code. So my sort of workaround for this problem was that I started doing stuff as open source projects, which everybody understood that if it was an open source project, then nobody owned it. It was just like a library that you pulled in. The fact that I'd written all of the open source and was also writing the code for the client was kind of like neither here nor there. So that's basically how I got into it. It was just so that I didn't have to write the same thing over and over again.
But did you have any experience previously on 3D graphics or?
Only as a hobbyist. I'd done some OpenGL stuff just for my own interest. I'd written a couple of games, not for iPhone particularly, but I sort of understood the principles from that. I was pretty much just self-taught, and I'm sure I wasn't doing things efficiently. But with CoreAnimation, it's a very high-level API. Like, you don't really need to know any maths or anything. You sort of have to have an idea of like what a 4x4 matrix is for, and like how it's, kind of like how it's manipulating the values. But yeah, beyond that, like, I mean, it does all of the maths for you.
And iCarousel helped on establishing your name in the community?
Yeah, I think that was my first, like, well, it was close to being my first like big open source like thing that I actually released anyway, but it certainly was by far the most popular of all of the things I released. I mean, I had maybe like 50 different open source libraries that all did various different useful things.
You had iVersion also, right?
Yeah, a lot of things. I had a library called iRate, which was basically for showing like a rating prompt, because like at the time everyone lived and died on how many stars they had on the App Store. And that turned out to be quite controversial. It sort of got some negative attention, but it was also very popular, but not in the same league as iCarousel.
And by building iCarousel, you got all the knowledge about CoreAnimation. How did you learn all the little details about CoreAnimation? Did you have an experience on CoreAnimation on the Mac, maybe?
No, not at all. I mean, CoreAnimation did come out for the Mac originally, but I didn't really, I was never really a Mac programmer. I mean, even now, I've written far more iOS code than I've ever written AppKit code. My understanding of the history of CoreAnimation is that it was really created for iPhone. It's just that it happened to ship on I think it was macOS Tiger, like a year before or nearly a year before the iPhone was announced. But it was always intended to be an iPhone-like library. It was one of the first kind of, I guess, cross-platform, APIs that Apple did, and one of the things that kind of started tying the two different platforms together. But no, I didn't have any experience of it from before iPhone programming. It was purely just from basically doing my job and trying to get the iPhone to do these like, intricate things that the designers were asking us to do that nobody was really sure how to do.
Right. And nowadays, they're much easier with SwiftUI, right? You just, with a few lines, you can declare things to build with CoreAnimation.
SwiftUI still uses, I think, some CoreAnimation stuff under the hood, but it's kind of much less explicit now, I guess. Like, SwiftUI's take on animation is much more declarative. I mean, CoreAnimation was also, in some ways, what made it easy or clever was the way that it was relatively declarative compared to a lot of animation libraries at the time. So for simple things, you would mostly just say, here's where stuff is, here's where I want it to be, here's how long I want it to take. And it took care of the actual animation for you, rather than you having to do like a bunch of stuff with keyframes and so on. And there was kind of this interesting relationship between UIKit and CoreAnimation where they were kind of connected but worked slightly differently. In CoreAnimation, everything animates by default, and in UIKit, everything's not animated by default and you opt into animation. And it was interesting exploring how those two things were glued together. I didn't learn CoreAnimation from doing iCarousel. I did iCarousel because I already had learned some CoreAnimation. But what happened there was by doing iCarousel, I kind of gained some notoriety, which then led to a publisher, Pearson, approaching me about writing a book, and they suggested CoreAnimation as a topic, and I said, sure, I know a bit about that. And in order to write the book, I then did a lot of research and learned much more in depth what was going on.
That makes sense.
So yeah, having done that, I think I then had a pretty solid understanding of how CoreAnimation works, sort of like from top to bottom.
Yeah. A lot of people, whenever they need to teach it, either if it's a talk or a book, that's how you really learn it.
Right. Yeah. I mean, I think one of the reasons I like to do things like give talks or like write posts about things is because it's a good way to learn, right? Like you never learn something as well as when you try and explain it to somebody else.
Totally agree. Yep. And fast forward a few years, Swift is announced. How long after that you came up with the idea of SwiftFormat? When did you feel it was a necessity?
So I'd always been kind of annoyed by the lack of a good formatting solution for Objective-C, actually. There was a lot of different styles that people adopted for their Objective-C code, and there wasn't really any good way of like
Forcing.
applying consistency. There was Clang format, but it was extremely fiddly and difficult to configure and so on. And, I guess it had crossed my mind to try and write my own formatter. Like parsers and that kind of thing is something I'd always found interesting. It's kind of like parsers and 3D were my two kind of hobby, but it wasn't practical really for me as an individual to write a formatter for Objective-C, because Objective-C sits on top of C, and C has things like macros, and it's basically like an almost infinite number of like different like weird syntaxes that you might have to consider. And then there was C++ as well, and it just didn't seem like a viable thing. And I mean, it seems strange now in retrospect because Swift has grown into quite a complex language, but at the time Swift seemed a lot simpler.
Yeah.
It didn't have like all of these kind of macros and weird sort of syntax.
And the number of reserved keywords.
Right, yeah. Yeah, so I mean, it seemed like an achievable thing. And my motivation for doing it is that basically I just started at a new company and I was really using Swift heavily for the first time at this point. And they had essentially no like code style standards whatsoever, different indenting, different spacing on, even within the same file. And it was just like a mess. And it was one of these things where I could just tell that culturally, like nobody else cared about this, right? Like there was no way that I was going to be able to make anybody else care. And I didn't want to spend all my time kind of in code reviews just annoying people by saying, hey, would you mind like, sorting out this white space? Like it's not really the right sort of, thing to use like GitHub PR reviews for. So I thought, well, if I just have if I just make a tool that just applies a style, then like presumably people aren't going to mind that. Like, if it's just something that happens automatically, they don't actually have to worry about it. Like if they don't care about styling, they're not going to care if I restyle stuff. So I just thought, okay, I'll just do this in my spare time then as a like interesting activity, and then hopefully it'll also make my work life easier, or at least more pleasant.
Yeah, and so how did you approach the implementation? Because parsing is not a simple topic. And
no, so I did initially look around to see what else there was available. Apple had a tool at the time called SwiftFormat. Like it was this thing that was checked into their repository, but it was kind of, it seemed like somebody had maybe like done some bare minimum effort there and then abandoned it because it hadn't been touched for a long time. Sort of much more like well known at the time tool was something called SwiftLint, which was a linter. My boss at the time was very opposed to us using SwiftLint because he felt like, things that bug you on your PRs about whitespace were very annoying. This is one of the reasons why I didn't want to be the person bugging people about whitespace on their PRs. So like I didn't even suggest like maybe trying to integrate that. At the time, SwiftLint didn't have, I think, any automatic formatting capability, so it couldn't auto format any of the rules
right.
that it linted about. It was purely just recognizing these issues and then flagging them
and
rather
telling
than
where they
fixing
are.
them.
Yeah, and it used source kitten.
Yeah, so SwiftLint was written by JP Simard, and he wrote Source Kitten, which was a Swift wrapper for SourceKit, which is Apple's compiler sort of library. And I took a look at how it worked, and SourceKit didn't really produce the output that I needed. So SourceKit produces an AST, abstract syntax tree, basically, which is sort of the syntax of your file, but with all of the white space and comments and all of the unnecessary like stuff removed. Anything that's not useful to the compiler has been stripped out. And I couldn't see an easy way of getting it to give me, well, basically you need all of that stuff. Like if you want to write a formatter, you actually care about things like
you
white
need
space
the
and so
AST.
on. And I also, in principle, you can write a formatter just with an AST if you're doing like a total formatter, right? Like if you're basically deciding everything, like I'm going to, have a principle for where every single line break goes, where every single space goes, and all this kind of stuff. But that seems like too much work. Like I didn't want to have a formatter that was that opinionated initially. I just wanted something which could make surgical changes, like, removing blank lines, applying indenting, but not having, complete control over the entire formatting of your file. I think if I tried to do that as a first step, it would have been too much to take on. So after tinkering with Source Kitten for a while, I just decided like, what I actually just want is, the white space and token information, and then I can just easily figure that out myself. The initial version of SwiftFormat didn't even know about keywords, for example. Like it didn't distinguish between keywords and identifiers because for the purposes of formatting, I didn't really care about the difference. The initial version was literally just doing stuff with white space, making sure that there wasn't multiple spaces between identifiers, making sure that, things were indented properly. And so it was actually quite simple. Basically, all I had to do was write a tokenizer, something that could just go through the string of the source file and identify, this is this is like a symbol, this is a bracket, this is an operator or whatever, and that's all it does. And I mean, actually, like SwiftFormat isn't very much more sophisticated than that now. It's pretty much still just doing the same thing.
The same idea.
Yeah.
But how it had evolved from there?
Well, the main thing that's evolved is just the complexity of the rules. So there's now much more ambitious rules than there were at the time. And in many ways, the rules in SwiftFormat are sort of too ambitious in that it's a lot of the time the rules are doing things that can't really be done at the level that it's operating. So one of the things that SourceKit does, which SwiftFormat doesn't, is that it actually compiles the project and makes sure that it's valid code.
Valid
right?
Swift.
And most of the time for a formatter, you don't need that. But for some things, you do. Some things can't really safely be done without having that information. And people often ask me to write rules like, like we have this naming convention. Can you write a rule that renames all of these functions to follow this convention? It's like, well, I can't really do that because SwiftFormat
That's not the point.
Well, it's not that it's not the point. Like I have no objection to doing that. I think it's a reasonable thing. My view of what a formatter is maybe like broader than what a lot of people would consider. It's just not actually possible because when SwiftFormat is operating on a file, it treats that file in isolation, right? It has no idea of the wider context. So if you have a function name in a file and you rename it, if that's referenced in some other file somewhere, then you're going to break the program. And it can't know that it's doing that because it doesn't know about the rest of your project. One of the things that makes it fast, and SwiftFormat is very fast, it's still faster, I think, than any of the alternatives, is that it can format all of the files in parallel. And again, it's able to do that because it treats them all in isolation. There's no shared information between them.
Yeah. And you mentioned the SwiftFormat, the other project by Apple.
Yeah.
And nowadays it lives under its own repository.
Yeah. So the only thing that the new Swift-format has in common with the old one is their name, as far as I can tell. At the time when I wrote SwiftFormat, Swift syntax didn't exist. It wasn't available as a library. It didn't even exist as a concept, really. SourceKit isn't suitable for making formatters or operating at this level, as I said, because it basically produces an AST only, and what you want is a CST, a concrete syntax tree. libsyntax was the framework that Apple exposed for handling that kind of level of information. And Swift syntax grew out of libsyntax. Initially, it was just a Swift overlay for libsyntax, which is a C++ library. And then eventually it became a standalone library. But this was many, many years later. So since 2017, when Swift syntax first appeared, and then a few years later on, when it eventually became a standalone library, it then became possible to write a formatter based on that, and that's what the new the format from Apple is based on. So it's using the Swift syntax library.
So what are the practical differences?
So Swift syntax is a full parser, not just like a token level thing like SwiftFormat. It actually fully parses the file. It still has the same limitations in terms of it only operates on a single file at a time. It doesn't have any concept of what these symbols that it's looking at are. It just knows that it's valid syntax. And it's also capable of, applying some correction. Like if it can handle invalid syntax basically as well and do so safely. I mean, the main advantage to Swift syntax is, first of all, because it's a proper parser, it gives you hierarchical information. So, for example, you can know that a given keyword or a given symbol is part of a function declaration. In SwiftFormat, I have to kind of infer that, or I have to, the rule itself basically has to be like a mini parser that is capable of understanding the relationship between neighboring tokens and sort of maybe building its own simple sort of syntax tree for whatever it is that it needs to do. And some of the rules, that's very complex, and other ones, it's very simple. With Swift syntax, that's all done for you out of the box, which is quite convenient. It comes at a cost, though. There's two costs. One is the library itself is very, very large. Like, it takes a long time to compile and is a big dependency. And also it's slower. Like, Swift syntax is very fast for what it does, but what it does still takes longer than what SwiftFormat does, which is just, the lexical stage.
I see. That makes sense. And I have a question that is less technical and more general, if we could call that.
Hmm.
You've been doing iOS for a while. How do you keep yourself fresh and challenged, and how do you not get bored from doing regular stuff?
I mean, as I said, like I have a few things that I personally like passionate about. Like I really like parsing stuff and language stuff. I like 3D graphics and so on. So mostly I just, like my day job doesn't usually intersect with these interests. Like occasionally it does. Like with SwiftFormat, I was able to kind of like do a bit of parsing stuff, and whenever I get the opportunity to kind of find an excuse to do that, I will. But for the most part, like my day job is pretty regular iOS development. People say like we just turn JSON into table views or whatever. I think that's
rectangles.
Everybody does a fair bit of that, and I mean I enjoy that. But yeah, it's not generally, there's not that much novelty to it. I do like. I think I find it difficult to motivate myself to learn new things unless I have like a reason to do it. So like a project that requires it. And I think probably if I didn't have kind of a regular iOS job, I probably wouldn't have been able to keep up with things like SwiftUI and so on, because I don't really have like a side project that needs them. So I just won't learn them. My own projects just have ended up being just doing the things I already know how to do, like over and over again. But I have enough variety in the things I do as like sort of programming hobby tasks, and also, the things that come up at work, that I don't find that I get bored.
I see. And did you have any opportunity to do Swift on the server? Is it something that interests you?
I used to do web development, and then I moved into doing like mobile and application development. And it's interesting how things have they keep going sort of full circle in a way. Like, web developers are now making desktop applications, and desktop application languages like Swift are now moving onto the server. And it seems like sort of everybody wants to kind of take the tool they're familiar with and then use it in these different domains.
Everywhere.
But I think for me, kind of moving to mobile and application development meant that I don't really have any interest in going back to the server side particularly. I mean, maybe if it was, if I had a good reason to do something on the server, I guess it would be nice if I could do it in Swift, but I'd need the reason to do it in the first place. Mostly I don't. So yeah, it makes sense to me that you do server-side stuff in Swift. It seems like a good language for it. I think one of the reasons partly why it's difficult for me to go back to things like web development is because having sort of tried, strongly typed languages like Swift and things like JavaScript and PHP and all these languages seem quite primitive by comparison. So I guess, in a sense, I do understand the motivation for wanting to do Swift on the server. But at the moment, it's not something that I have any interest in doing.
So you mentioned server-side Swift, that it's not something that interests you so much. What do you feel Swift is missing, and that's an area where you could be more interested into, or maybe you think it's missing maybe components or aspects of other languages?
So I guess one of the reasons I'm interested in sort of parsers and syntax and so on generally is I really like sort of doing meta programming type things with languages. So things like, building tools, building tools for working with the language themselves. There's a bunch of tools in the Swift ecosystem, things like sorcery for doing code manipulation. You've got the macros system now. I recently gave a talk about Swift syntax, which is Apple's system for like parsing Swift code. And the topic of that talk was this idea of like, what if you could write an eval function for Swift? Like, could you write Swift code that interprets and runs Swift code? And Swift syntax would be an obvious component in such a system. I mean, the short answer is like, no, that's a really hard thing to do, but it's a fun idea. And another interesting related thing is Swift WASM, the WebAssembly for Swift. There's now a library to run compiled WASM code in Swift, like basically to interpret it. So, what if you could use Swift syntax maybe as part of a tool chain to, at runtime in a Swift program, compile Swift into WebAssembly and then run it also in Swift. So it's kind of like Swift end to end. You could then have some of the capabilities in Swift that we currently have in scripting languages, even though it's a compiled static language and so on, which generally makes it's a big barrier to doing like very dynamic stuff with Swift. If you had that like end to end toolchain all written in Swift, then you could have, you could make plugin systems, for example. So like for SwiftFormat right now, if you want to add a new rule, you have to like go and edit the source code, recompile the binary, and then you can add your rule.
And distribute to everyone.
And it's not really practical. And then of course, like distribution is also a huge problem because you've got all the signing and everything, and you have to have an Apple developer account, and it's just too much of a pain for typical people. But if you had this kind of ability to just evaluate Swift code at runtime, even if the performance wouldn't necessarily be as good, you could write your SwiftFormat rules just as a text file and then import it, and you could have like a plugin system, right? And you could just write your own rules and run them without having to rebuild everything and go through Xcode and go through distribution and signing. You could do cool stuff in apps. It's possible to make apps scriptable right now using JavaScript because Apple provides like a JavaScript runtime.
Core.
But there's no way to make them scriptable using Swift really because there's no equivalent thing. So yeah, I think that's a cool area. That's something that interests me.
But do you think it's by design like this, or
no? I don't think Apple is like fundamentally opposed to people running Swift code at runtime. I mean, it might introduce some security concerns, but probably nothing that's not already, a problem with things like running JavaScript. And over time, Apple has become more relaxed around this. Like in the early days of the App Store, they had a no virtual machines policy, and then that became sort of like only our virtual machines, and now it seems to have just pretty much gone away altogether. I think they're not opposed to it. It's just a matter of focus, right? Like with server-side Swift, with running Swift on Android, with running Swift on Windows, like with WASM, like all of these things, it's not that Apple doesn't like them. It's not, I mean, in a lot of the cases, it's actual Apple employees are pushing these things, but it's just not really part of the company strategy. I think that's why there's not a lot of like momentum behind them. It's, people who are enthusiastic about these things are pushing them forward, but it's not Apple themselves.
Yeah. Makes sense. All right. These are all very interesting answers, and it's really interesting to learn about the origins of SwiftFormat and how you build it. We'll leave links for these projects on the show notes and also for your socials. Thank you so much, Nick, for your insights, for sharing your experience and your tips. Thank you so much, and we'll be in touch. See you next time.
Thanks.
Bye-bye.
Bye.